Okay, so today we are going to learn in electric circuit the potential divider circuits. Okay, like we will see the transistors and logic gates. Okay, in today's session. So potential divider circuit, you have basically seen that a power supply potential difference. Okay, as you have 12 volt battery, so it will provide you 12 volt, that is fixed. But if we want 6 volt, if we want 3 volt for some circuit or for some component, so how you are going to give it 3 volt, 4 volt, 5 volt or 6 volt if you have 12 volt battery? Okay, so these type of things are said to be potential divider, these type of circuits which divides the potential. So that is said to be the potential divider circuits. Okay.
Yes.
So split, we can split it. So if you connect two resistance in series, so potential is divided, isn't it?
Yes.
Okay. So we can use resistance accordingly. Whatever voltage we require, whatever potential difference we require, so we just connect it accordingly. Okay.
Yes.
Like you have seen two resistors RA and RB connected in series across the 6 volt power supply. The potential difference across the pair is 6 volt. If the potential difference across the pair is the 6 volt, then the PD at X, okay, I told you this thing. So electronic circuits, electronic circuit, what is electronic circuits?
It makes use of images of components.
Yeah, it's a combination of components, combination of electric component. Okay, so there may be resistance, battery, and capacitance. Okay, inductance. So if you have a certain set of components that are connected together, so that is said to be the electronic circuit. Okay.
Yes.
So electronic circuits such as those found in phones, radio, MP3 player and television sets make use of a number of other components to control the way that current flows in a circuit. In this section we will look at transistor and a logic gates. So basically two things we will study there in this section, that is transistor and logic gates. Okay.
Yes.
So transistor is an electronic component that 3 terminals or connections. Basically transistor is a combination of 2 diodes. Okay.
Yes.
Do you remember that last class I told you about the diode?
Yeah, the diode, LED light. It ensures that current moves in only one direction. Right?
Yeah. So that is called as PN junction diode. Diodes are PN junction diode. Okay.
Yes.
PN junction diode. So this is the symbol for diode. Sorry, this one. Okay. So P. Okay. One diode we connect it in forward bias, another diode we connect it in reverse bias. So that becomes PNP junction diode. Okay.
Yes.
PNP junction diode, and another one is NP. If we connect this PN here, so it becomes NPN. So there are two kind of transistors are there, that is PNP and NPN. Okay, and there are certain combinations as well. So on the basis of combination, they also can be.
Sir, but what exactly does a transistor do, sir?
Transistors divides, basically it's a potential divider. Okay.
So what does it divide, sir?
Potential and current as well, and it also controls the potential and current in a circuit.
Yeah.
Okay, so we'll understand it.
Yes.
No worries. So transistor is an electronic component with 3 terminals. I told you it is having 3 terminals. Okay.
Yes.
19.17. Where is 9.19.17? Yeah, this one. It looks like you have seen these components. So it looks like this one. So these are said to be the transistors, and they have three legs. Okay.
Yes.
This is called as base, this is called as collector, this is emitter. Got it? So
Yes.
here you can see here current passing through IB. Okay, IB, that is a base current. The current flowing in base. So these are three legs. One is called as base, one is called as collector, one is called as emitter. We'll understand it, how it works. So IB means the current flowing in base, IC means current flowing in collector, and IE means current flowing in emitter. Okay.
Yes.
We'll see it, how it is decided whether it is a base or emitter or collector. But the three legs are said to be base, collector and emitter. Okay. The circuit in which we are interested, a transistor acts as a device for controlling the flow of current. As I told you, it controls the flow of current. Okay.
Yes.
Okay. So we'll see the transistor is connected so that there is a PD of 6 volt between the collector and emitter. So potential difference applied between collector and emitter, let us say for an example, we are applying 6 volt between the collector and emitter, current wants to flow from the collector to the emitter. So you can see here in between collector and emitter there is base. Okay.
Yes.
So by applying a base current, we can control the current in emitter. Okay. As you see, it is 6 volt in between collector and emitter. So whatever current you want in emitter, so that can be controlled by a base. As you control the speed of fan by regulator. Okay.
Yes.
So that behaves like a regulator. Okay.
Yes.
So that the arrow indicates the direction of current flow. The transistor has a very high resistance, so no current flows. However, so it is a very, I told you, it is a combination of diodes. Okay, one is connected in forward bias, another one is connected in reverse bias. As I told you, it is a PNP junction diode. Two types of transistors are there. That is PNP and NPN. Okay.
Yes.
So
Yes.
PNP is formed by connecting two diodes, PNP. So PN means it is a combination of PN plus NP. Okay. So you can see here, this one is in forward bias, this was in reverse bias. Okay.
Yes.
And in case of NPN, NP plus PN. So always it is connected in, one is in forward bias, another one is in reverse bias. Okay.
Yes.
N means negative of the diode, P is positive of the diode. Okay.
Yes.
So the transistor has a very high resistance, so no current flows. It is having a very high resistance because one diode in the transistor, one diode is connected as a reverse bias. So reverse bias, it has a very high resistance, there will be no current flowing. Okay. But you can control that. So no current flows, however, if a small current flows into the base, this greatly reduces the transistor's resistance. Now, if you have base current, then it can control the current in, even it can control the resistance of the transistor. Okay. So if you have a current in base, so then resistance will be decreasing. Okay. So a small current flows into the base, this greatly reduces the transistor's resistance, and so large current flows from the collector to the emitter. So if you have base current, then current will be flowing from collector to emitter. Otherwise no current flow will be there. Got it?
Yes.
Hence a small base current IB permits a large current IC to flow. Until unless you don't have base current, the current will not be flowing into the emitter. Okay.
Yes.
So that is the main idea behind this transistor. So Now into the collector, the two current can join together and flow in through the emitter. We can show that this is a formula IB plus IC, as IB is flowing here. So IB plus IC will be equal to IE. Okay, but this IB can make very big impact. However large it is, that will be large as IE. Okay.
Yes.
So hence a small current IB controls a large current IC. When no current flows through the transistor, we say this is off. Okay. So when a current flows, it is on. So the transistor acts as a switch controlled by the base current. The basic idea about the transistor is. Okay.
Yes.
Whenever you have base current and whatever current you want to flow from IC to IE, so that will be controlled by IB.
Yes.
No current in IB, then you don't have output. Okay. So that means it is switch off now. Got my point?
Yes.
So if you have base current, then it will be switch on. That means it is a just behaving like a switching circuit. Okay. So reduce your IB, you will not be having output current. Okay.
Yes.
So a practical switching circuit. Now we'll look an example of a circuit in which sufficient current can flow through a transistor to operate a buzzer. So this circuit sounds an alarm when the temperature rises. It could be part of a fire alarm system. Okay. So as its temperature rises, so fire alarm system works. The input to the transistor is a potential divider circuit on the left, consisting of a fixed resistor and a thermistor connected in series. The resistance of the thermistor decreases as if it gets hot. So to switch the transistor, we need a current to flow into the base. For to happen, voltage at point X. Okay. So let us say this circuit. Okay.
Yes.
So this is thermistor. 6-volt battery is connected here. As the temperature rises, so that works. Thermistor will work. Okay. If this work, then what happens? Then current will flow into the base. Okay.
Yes.
And if current will flow into the base, then this circuit works and this buzzer will go on. That is a simple thing. Got my point?
Yes.
Until unless you don't have current into this section, that transistor will not go on. And if the transistor is not on, that means buzzer will not blow. Okay.
Yes, sir.
Got it? This one idea? This is
Yes.
just a simple example of transistor, how it works. Got it? It is a practical example. This is resistance, this is resistance. Got my point?
Yes.
So a transistor acting as switch, it switches the buzzer on when the temperature rises. So this will happen when the resistance of the thermistor is low, that is when it is hot. So there is how the circuit works. When the thermistor is cold, its resistance is high, so current will not flow. The voltage at point X is low, and so the base current IB flowing into the transistor is too small to cause a current to flow through the transistor is off. So if the transistor is off, that buzzer will not blow. So when the thermistor is hot, the resistance is low. So the voltage at point X will be close to 6 volt, and this voltage makes a small current flow into the base of the transistor. The resistor is there to make sure the current does not get into big. This allows a large current IC to flow through the transistor which is on. Now it will be on as the thermistor is hot. So the current also flow through the buzzer which buzzes. So 19.19. Now this one. Show how we could achieve the same thing using a relay. So relay also can be work. In this case, the rising voltage at X. Using a relay in place of a transistor is an automatic fire alarm circuit. Compare this with the circuit in figure 19.18. Okay.
Yes.
So a transistor circuit in which a lamp is switched on when the LDR is into the dark. The same thing we can use in LDR. Okay.
Yes. Yes.
So we can use relay also here. Okay, as we have seen, like once we were studying thermistor, then we have seen so what happens if we connect a relay over there?
Yeah, it will turn on, right?
Yeah, it will turn on. It will turn on as the current flows into the thermistor, that will turn on. Okay.
So, but the relay, like it safely turns on the other circuit, right? Because the voltage is too high for us to handle.
Yeah.
That's what a relay does, right?
Yeah, we can alternatively use relay here, but the best thing is using transistor. Okay.
Yes.
Because relay is used whenever you have very high voltage to operate. Okay.
Yes. Okay. So, but isn't this also high voltage, sir? Then why do you use transistor instead?
No, it's a very low voltage. Buzzer is a speaker. Okay.
Then why do you use transistor instead, sir?
Because it acts like a switching circuit. You need very low base current here. Okay.
What if high base current comes in then?
Yeah, base current will be flowing if thermistor is hot.
Okay.
Okay. So as the base current is flowing, so then circuit will complete, and if circuit is complete, then the transistor will give you the output. Okay.
Yes.
Because before earlier, once thermistor was cold, so there will not be current in this resistance. Okay.
Yes.
So as your thermistor is hot, so that will give you that will give you the way to flow that current into this one. So as the current is flowing into this one, so that resistance will also come into the picture. Then this will be having a very less base current. If you have a base current into that, then transistor will operate. Okay. So that circuit will also be completed.
Obviously.
Got it?
Yes.
Okay. Once you have LDR, light sensor circuits, I already told you how LDR works. These are light sensor circuits. Okay.
Yes.
LDR is there. As you have light on that, so that circuit will operate, otherwise circuit will not operate.
Yes.
Okay. So that is also an example. So you can use LDR as well. So as this LDR works, so current will flow as you have light on LDR. So as you have light on LDR, current will flow. So then current will also flow into this circuit. Okay.
Yes.
Then this will be working. So we could set up similar circuits using you can see the automatic bathrooms. Okay. As you enter into the bathroom, then light will on. Okay. Even there are sensors on tab also, washing tabs. As you go in front of the tab, then it will give you water, otherwise it will be switching off. Okay. What you are doing? You are blocking light. Okay.
Okay.
So it is working in a reverse process.
Okay.
Okay. So whenever there is a light, it will not operate. If there is light, it will operate. If there is no light, it will operate. Okay.
Yes.
So that is the same thing. So we could set up similar circuit using transistor and relays to respond to changes in light levels. In this case, the thermistor would be replaced by a light dependent LDR. You can replace LDR with thermistor with LDR. As the brightness of the light increase, the resistance of the LDR would also decrease. So eventually this would switch on the transistor on, and the current through the relay would close the switch. This could be used, for example, to warn a glass house operator when the sunlight was becoming too bright and might damage the growing plants. Okay. So that
Yes.
can be used in a glass house. As the light is very high, then that will switch on. Okay.
Yes.
So if you set up the potential divider circuit with the resistor and the LDR as shown in figure 19.120, it would operate in a slightly different way. This could be used to switch a light on automatically at night. Can you see there are some sort of things that like the solar lights. Okay. How it works? As it is a dark, they will switch on automatically. Okay?
Well, because the LDR is
Yeah,
not receiving light.
because of LDR. Okay?
So, but why do we switch on? Won't it switch off if light is not
Yeah,
there?
you can use you can use certain type of combinations of transistors. Okay?
Okay.
So whenever you want, you can use it in a reverse process also. Okay, when there is a light, if you want to use that, whether when there is a light it will be on, so you can design it. Okay.
Yes.
So during the day the resistance of the LDR would be low and so would the voltage attract, switching the transistor off. So you can use it in both ways. So that is an example. Okay.
Yes, sir.
Yeah, a transistor circuit in which a lamp is switched on when the LDR is in the dark. So as you have dark, the light will on. Okay.
Yes, sir.
So analogs and digital. Now we'll see. So if you use certain combinations of transistors, so that is called as digital circuits. So you can
I
design.
think we have this syllabus. I don't know. We have this.
You just check it.
Not learned, but
Just check it with your book.
mm,
Analog
no,
and
sir, I don't. No, sir.
nothing. This topic is not there.
No, sir, not this one.
Okay. So have we finished all the topics?
No, sir, there's the formulas left, right, sir, for electricity.
Formula.
So, like, yeah, like static electricity and all of that, like the formula of resistance, of charge, and all of that.
Okay. So switching circuits are not there. AND gate, NAND gate, NOR gate. Gates.
No, not this one.
Gates are not there. Okay. Okay. Is it there electrical safety?
No, yes, we can do this.
Okay. So electrical safety is very must thing you understand. Okay.
Yes.
So mains electricity is hazardous because of the large voltage involved. If you come into contact with a bare wire at 240 volt, you could get a fatal electric shock. Here you will look at some aspects of the design of electrical system and see how they can be used safely. So there are certain things you must remember, that once you are working on electricity and once you are working on a circuit, so that you should be aware of these things. So electrical cables, okay, that must be of standard quality first of all, and wherever you want 5 ampere, so then 5 amperes you use 5 ampere wire. If you want to have 15 amperes, so that is a separate wire. 15 amps wire and 5 amps wire, they both are different wires. Okay, so you have to use whatever rating of current is there, you have to use wires accordingly. Okay, if you are using 5 amps wire in 15 amp circuits, what will happen? It will
So,
burn.
like, not enough electricity would come, right?
No, not enough. It will burn your circuit.
So, but why? You're using less, right?
You have 5 amps circuit, 5 amps wire, but your equipment is using 15 amps.
Oh, yeah, then it will burn, yes.
Yeah, that will burn. Okay, so
Yes.
you must use appropriate wire first thing. Okay,
Yes.
so like you have fridge AC, so that wire will be thicker. Okay,
Yes.
so that is 15 amps wire. So cable of different thickness are chosen according to the maximum current and they are likely to have flowing through them. 5 amps, 15 amps, 13 amps. Each cable has live, neutral and earth. So 3 wires are there in a cable. One is live, one is neutral, another one is earth. Okay. Green one you can see, green one will be, there are different color codings for that. Okay.
Yes.
So if the wire in each cable are insulated from one another, they are insulated and the whole cable has more protective insulation as well. So around the outside it is insulated, is damaged, there is no chance that the user will touch the bare wire and get an electric shock. There is also a chance that current will flow between 2 bare wires or from one bare wire and any piece of metal, it comes into contact. Since you will be having 3 plug sockets, isn't it?
Yes, sir.
Like this. So the above one is said to be earth. This is said to be neutral. Okay. This is your live wire. Okay. So basically
Yes.
the voltage of this live wire is 240 volt and your neutral is 0 volt. Okay.
Yes, sir.
So once you insert the plug and switch on, what happens? Current will flow if there is a potential difference. That is the thing, that is the concept of current.
Yes.
So there is a potential difference between these two, live and neutral, isn't it? That is 240 volt potential difference. So current will flow. Okay. So current is flowing into the circuits, current is flowing into the appliances. So let us say this live wire, somewhere this live wire touching with earth. So what will happen? This
You get some of the current will get transferred.
this earth is also at 0 volt. Ideally it is at 0 volt. It varies from 0 to 5 volt. Okay. And what is earth? What is earth?
It touches the ground.
Yeah, that is ground. Okay. So that is basically connected to the ground. Got my point? How it is connected to the ground? Because if this is touched, this is short circuit. So what will happen? That current will pass through the ground. Okay. So as you touch the system, as you touch the appliances, you will not get shock. Because current will flow whenever it has path. So the path is provided by earth. So current will not flow through your body because it is already passing through the earth. Okay.
Yes, sir.
So that is the main safety precaution as every device is connected with earth. Okay.
So I think basically current is transferred to the earth, right?
Yeah. Basically your every appliances body of the every appliances is connected to this third socket, that is earth. Okay.
Yes.
So every appliances is earthed.
Yes, sir.
So another hazard can arise if an excessive current flows in the wire. They will heat up, the insulation may melt, causing it to emit poisonous fumes or even catch fire. Thus, it is vital to avoid using appliances that draw too much current from the supply. Fuses helps to prevent this from happening. So another safety device we use, that it is a fuse. Okay.
Yes.
So basically fuse is connected with live wire. So if excessive current is drawn by the appliances, so fuse is having a, basically if your circuit is drawing 5 amps current, so fuse will use there for 5 amps. Okay. If it is drawing 10 amps, so we'll use 10 amps fuse. If it's drawing 15 amps, then we'll use 15 amps fuse. Okay. So what happens when there is an excess current? So that fuse will blown off. Why? Because it has excess current. It can sustain up to 5 amps. So if it is having 6 amps, so that will be blown off. Okay. So that will protect your appliances. That will be protecting your electronic circuits. So it is used in the very beginning. Okay.
Yes.
So any current which is flowing into the circuit, first of all it will flow into the fuse. Okay. So it is also a safety device.
Yes.
So this is an example of fuse. So 5 amp fuse, rating is written on that fuse. Let us say it is 1 amps fuse, 2 amps fuse, 5 amps fuse, 15 amps fuse. So basically it's a glass house, and in that glass house there is a wire connected from one end to another end. Okay.
Yes.
So physically you can see whether the wire is blown off or not. It can be seen.
Sir.
Okay.
Yes.
So that is called as Cartesian fuse and fuse wire. The thicker the wire, the higher the current that causes it to blow. The circuit symbol for a fuse. So that is a circuit symbol for a fuse. Okay. In resistance, this line is not there, but in fuse the line is through all. Okay.
Yes.
So it is important to choose a fuse of the correct value. As I told you, it should be an appropriate value fuse. So correct value in order to protect an appliances, the current rating of the fuse should be just above the value of the current that flow when the appliance is operating. If you are using 5 amps fuse and your appliance is also working on 5 ampere, so is that appropriate to use only 5 amps fuse?
You can use 5 amp, right?
It will be above than 5, because basically 5 amps is flowing. Okay.
Yeah.
So it must be
Yes.
above 5 amps. Okay.
Around 6 or 7 amps, right? Sir?
Yeah, around 6. Got it? So it depends upon the equipment, what equipment you are using. Let us say 6 amp will be dangerous to the equipment, so we will be having 6 amps fuse. So as 6 amps current is flowing, so that will be blown off. Okay.
Okay.
So a 2 kV heater works on a 230 volt main supply. The current flowing through it in normal use, it is 8.7 ampere. Okay. So normally current drawn as 8.7 amps. What current rating would a suitable fuse have? Choose from 3 amps, 13 amps, 30 amps. What do you will choose? 3 amp will not work.
13 amp is best, right, sir?
13 amps is best. Okay. Because
Yes.
if you have 30 amps fuse,
Too much.
so that's a very high current. Okay.
Yes. Too much.
Generally it is using 8.7, so if you use 30 amps fuse, so that will not blow. Even at 15 amps it will not blow, even at 28 it will not blow, but your appliance will be blowing off before the fuse. Okay.
Yes.
So it must not.
Yes.
Now circuit breakers, you can see in your house there are circuit breakers, CBs. Okay, MCBs, basically we say it's MCBs. Okay.
Yes.
MCB is main circuit breakers, but you can see small CBs there, and there is a master CB. Okay. So master CB, what it works? Master CB will switch off all the CBs. Okay. So if there is a fire in your house, so what you will do? You will just switch off the MCB, the main circuit breaker. So it will switch off your all supply. It will cut off your all supply. Okay.
Yes.
So whenever there is an electric fire, so what you will do first? You will first switch off the MCB.
Circuit breaker.
MCB, main circuit breaker. Okay. So
Yes.
there are two types of circuit breaker used in electrical safety. Try not to confuse them. Both work using electromagnets. This is working on electromagnet. Okay. But
Yes.
will not consider the detail of their construction here. Constructions will not study here, but we just, a trip switch can replace a fuse. Okay. So that is an advanced version of fuse. If you have excess current, that will trip off. Means it will go automatically off. Okay.
Yes.
So excess current will cause excess heat, and excess heat will cause that CB to trip off. Okay. So
Yes.
whenever there is excess current drawn, so that CB will be tripping off. That means that will cut off the supply. Okay.
Yes.
So a trip switch can replace a fuse. When the current flowing through the trip switch exceeds a certain value, the switch trips, breaking the circuit. Some modern house wiring systems use trip switches instead of fuse in the fuse box. So generally we don't have fuses in our main circuit board, MCB. Okay.
Yes.
There is a panel outside the home. So in that all CBs and MCBs connections are there. Okay. So as
Yes.
you have somewhere excess supply or some circuit or some appliance is your short circuit, then what will happen? That particular CB will trip off. Okay.
Yes.
Like for a room, you have 3 CBs and the fan is shortened. So what will happen? That particular CB will be tripping off. Okay.
Yes.
So if too much current starts to flow, the supply itself might overheat and be damaged. The trip switch jumps out and you may have a wait or a short while before you can reset it. So that will be switching off. Again manually you have to go and you have to switch it on. Okay.
Yes.
And you can check that what appliance making it to trip. Okay. You
Yes.
can check it one by one. A residual current device protects the user rather than an appliance or cable. In normal circumstances, the current flowing in the live and neutral wire are the same because they form part of a series circuit. However, suppose that there is a fault, someone cutting the lawn with an electric lawn mower has accidentally damaged the live wire by running over the flax with the mover. Some current then flows through the user rather than along the neutral wire. Now more current is flowing in the live wire than in the neutral. The RCD detects this and switch off the supply. Okay.
Yes.
So this is houses often have RCDs fitted next to the fuse box. School labs usually have 1-2 to protect students and teachers. So that will protect you from the shock. Okay.
Yes.
So in normal use, a current of, just answer these questions, try to answer these questions.
Yes, the first one is 5A, right?
Yeah, 5A. Okay.
Yeah. So like fuse of it is visible because if it like bursts, it's still safe. The other appliances do not get affected, right?
Okay.
For the 22nd,
Hmm.
the other appliances do not get burst.
Okay.
And then which device could you use in place of a fuse, like a circuit breaker, right?
Yeah.
In place of fuse.
Yes. Yeah. What hazards can arise when the current flowing in an electric wire is too high?
Yeah, it could burst. It could burst.
Yeah, there may be fire as well in
Yes.
the wire and in the electric
Yeah.
circuits. Okay, I think that completed the chapter. Okay,
Yes.
should we try some questions?
Yes.
Yeah, this one, 19.2. Draw a circuit in which two resistors are connected in series with each other and with a switch.
Sir, is there something before this in electricity, sir? Before circuits? Can you just check? Because I saw more topics before the circuits.
Okay, what the topics?
Yes, sir. Just can you just see what's the topic before circuits, sir?
Before
Yes, before the circuits.
Yeah, we covered all that topics. Resistors in series,
Yes.
relays. Before that was electronic component.
No, so before this whole thing, before this chapter,
Okay, okay,
previous
okay,
chapter.
okay, okay, okay. I think before this chapter, something is missing. You want to say that?
Yes, there's also static electricity and all of that.
Just a moment. Let me check.
Sure.
That might be another chapter.
Before this one, sir, I think it's the same sort of electricity, but yeah.
Yeah, that is static electricity.
Yes. So what's after that chapter?
The
next chapter
after this is electrical quantities.
After that is the circuits, right, sir?
Yeah.
We have to do those chapters also, sir. That's also an electricity. Will you
Okay.
leave some of both of them?
Okay. So we'll do electrical quantities. That is current in electric circuit, electrical resistance, electricity and energy. The topics you want?
Yes, that and static electricity.
Okay, static electricity. Yeah. So can we start from static electricity?
Yes, sir. No.
Okay. Because we have taken the last chapter of electricity and magnetism.
Yes.
Okay.
Take the first two chapters.
Yeah, magnetism it was, static electricity, electrical quantities it was.
No, magnetism, just static electricity, then electrical quantities. There's no magnetism, sir.
Magnetism, okay. So you want static electricity now?
Yes, static electricity and the quantities, that's it.
Okay. No worries. Okay. Static electricity. So there is a sparks in cloud. You can see there. So that is called as static electricity. Okay. Whenever you have you wear some nylon clothes, and if you remove that, there is also spark, because as it is a nylon cloth, so your cloth is charged by the friction of your body. Okay.
Yes.
So that is called as static charge. If you use plastic slippers and you are walking on the floor, and if there is an iron door, so if you touch that, there is a spark, little spark. Why it is there? Because your body is charged enough to provide a spark. Okay. So this is basically the charge. So because of this charge, whenever there is a path, so that charge will be discharging it. Okay, then if you are charging and by flowing the current, you will be discharged.
So that's all that is there in static electricity, nothing else?
Yeah, static electricity is charging and discharging basically.
That's it, or is there more to it?
Yeah, that is the thing only.
Then what about the after one quantities? What is there in that, sir?
Yeah, that was electrical quantities. Then current in electric circuits, the current in electric circuits and electrical resistance, electricity and energy. 3 topics are there.
So this you already explained, right, sir?
Yeah, charging and discharging.
Yes, you already explained that.
Yeah, we'll do it faster. So like charges repel, unlike charges attract each other. Positive will attract negative, negative will attract positive. Like charges will repel each other.
Yes.
Explaining static electricity, as you just rub that plastic rod with nylon cloth, so that will be, there will be charge on the rod. Okay.
Yes.
So charging can be done by the induction also. If you have a positive charge there and if you connect anything with that charge, so that charge will also be onto that another conductor. Okay.
Yes.
So that is, and even charge can be also there by induction. Induction means it is not in the contact of, let us say you have two spheres, one is positive charged, it is positive charged, okay, and you have another sphere which is not charged. So
Yes.
what will happen? This is positive charge sphere, so all electrons will be attracted by this, okay. They are not in contact, but what will happen? All electron will be there, this, like this, will be attracting towards this positive charge, okay,
Oh. Yes.
and positive charge will be repelled. So positive charge will be here on this, okay, that will go that side, electron will be coming towards this positive charge. What will happen if you earth it? If you earth this side, what will happen? That positive charge will go into the earth.
Okay.
Now this is negative charged sphere. Now remove this one, so your sphere will be negatively charged sphere. So that is called as charging by induction, okay.
Yes.
As they are not in contact, but the charge is there because of induction, okay.
Yes.
Friction and charging I already told you. Friction can also produce charge. Electric field. So electric field, whenever there is a charge, it will produce electric field, okay. Around it
Yes.
there is a imaginary field, so that is called as electric field, and these are said to be the electric field lines. If it is a single charge, so that from positive charge electric field line will be, direction of electric field line will be outside. If it is a negative charge, direction of electric field will be inside the charge, okay.
Yes.
If it is a combination of two charges, that is positive and negative, so electric field line will be from positive to negative charge, okay.
Yes.
What is electric charge? Do you know that?
Yeah, the electrons, right, sir?
Yeah, it is the combination of electrons. So once electrons are collected, so that becomes charge, okay. If you are donating electron, so that means you are positively charged. If you are accepting electrons, then that means you are negatively charged, isn't it?
Yes.
Okay. So charged particle, and the unit of charge is coulomb. It is denoted by C. And electron is having charge of 1.6 into 10 to the power minus 19. Electron is negatively charged particle, okay.
Yes.
Proton is positively charged particle, the same charge it has, 1.6 into 10 to the power minus 19 coulomb. Got it?
Yes.
Now the chapter is completed. Now it is electrical quantities. This is model of a circuit, okay. It has certain type of components. Whatever component we studied in the next chapter, that is electric circuits. Component we already studied. So
Yes.
electric circuit is a combination of that components, okay. Now current in electric circuits. Current means it is a just flow of charge. Current is a flow of charge. So
Yes.
current we can write it, current we denote it by Q, I, charge is denoted by Q, so it is I equal to Q by T. It's a rate of flow of charge, okay. The unit of current is ampere. Measuring electric current, the electric current is measured by ammeter. Okay.
Yes, sir.
Good conductor, bad conductor. Good conductor is a conductor in which current easily flows, and bad conductor, current doesn't flow into that. Okay. Like plastic.
Yes.
Plastic is a bad conductor, but iron rod is a good conductor. Okay.
Yes, sir.
So basically bad conductors you can call it like insulator. Okay.
Yes.
So good conductor, most metal including copper, silver, gold, steel. Good insulator, polymers or minerals, glass. In between there are too many metals. So in between conductor and insulator there are materials like semiconductors. Okay. So the example of semiconductor is junction diodes, transistors. So semiconductors are used there. Okay.
Yes.
So what is electric current? I already told you. And electric current is being measured by ammeter. Okay. So
Yes.
whenever you want to measure electric current, like if this is your circuit, this is your cell. Okay. You have fan here. So if you want to measure current into this resistance, so what you have to do, your ammeter has two wires. Okay. So you just have to break that circuit and you have to connect ammeter here. Okay. So whatever current is being flown into this resistance, so that will be shown into the ammeter. So ammeter
Yes.
is always connected in series. Okay. Just write down, it is always connected in series. There are analog meter and there are digital meters. Okay. Analog meter will be having a needle and some readings. Okay.
Yes.
So that needle will show you how much current is there. There are digital meters also, so that will directly give you the number on the display. Okay.
Yes.
So these are two examples. This is analog meter, this is digital meter. You can see here it is a needle and some readings are written on the display bar. Here you can see the direct answer, that is your current, that is 0.17 ampere or whatever it is. So it will show you directly. So nowadays your analog ammeter is not used, only digital ammeter is used. So milliampere is 10 to the power minus 3 ampere, microampere is 10 to the power minus 6 ampere. Okay.
Yes.
So current and electron both will flow in opposite direction. Okay.
Yes.
You can see here current flow is in this direction, electron flow is in that direction. So you just remember current and electron always flow in opposite direction. Okay.
Yes.
So I already told you I equal to Q by T. Electrical resistance we already
Yes,
we did it. Defining resistance, so resistance is by Ohm's law, it is V by I, it's a constant value. Okay.
Yes.
So resistance is always measured in ohms. Okay. As you have greater resistance, current will be less. As you have higher resistance, current will be more. Okay. The greater the resistance in the circuit, the smaller the current that flows. Greater resistance, smaller the current, and smaller the resistance, greater the current. Okay.
Yes.
So the greater the PD in a circuit, the greater the current that flows. So even you can, if you have higher voltage difference, so then also you will have higher current. Okay.
Yes.
And longer the wire, your resistance depends upon what? Resistance depends upon length. Resistance is universally proportional to the cross section area of the wire. What does it mean? If you have
As the area gets bigger, the resistance gets smaller, right?
area bigger means its thickness is
Yes,
increased.
smaller.
Its thickness. Okay, we are just talking about the cross section area. This one is cross section area. So as the cross section increase, that means thickness of the wire increase. So if the wire is thick, then its resistance will be less. Okay.
Yes.
So the longer the wire, the greater its resistance. The greater the diameter of the wire, the lesser is its resistance. So just have to remember it. There are certain questions. Okay. Resistance calculation. So it will be done by I equal to V by R.
Yes.
Okay. Length and area, we already discussed it.
Yes.
Electricity and energy, it's a last topic.
Yes.
So you have two types of current, that is alternating current and direct current. We already talked about it. What is alternating current? It is a sinusoidal wave. Okay. Whatever we
What
have.
does it do exactly? So the current keeps changing direction?
Yeah, its direction and magnitude always change.
Yes.
Okay.
Yes.
The greater the EMF of supply, the greater the energy it supplies to the charges. It drives around the circuit. Okay. Electrical power is V into I. Power is potential difference into current. Just you have to remember it, P is equal to IV. That is called as power.
Yes.
Okay. So power,
Yes.
what is power? Power is work done divided by time.
Yes.
Okay, and work is what? Work is the energy. Okay.
Energy transfer.
Yeah. So your power is work done by time. So work done will be P into T. So work done is what? It is just energy. So how much electrical energy is being transferred? So that will be calculated by P into T. So what is P? P is VIT. So that W will be VIT. So VIT will give you the energy transferred. Okay.
Yes.
So like we can see that an electric fan runs from 230 volt mains, the current flowing through is 0.4 ampere. At what rate is electrical energy transformed by the fan? How much energy is transformed in 1 minute? So already voltage is given, current is also given. So if you multiply that, that will be given as power. Okay. And time you must have taken it into seconds. Then your energy will be given in joule. Okay. There are certain units of energy, that is joule, that is watt. VI is what? Power, unit of power is watt. Okay.
Yes.
So watt per second is also the unit of energy. Okay.
Yes.
So P will be V into I. Now step 3, calculating energy transfer, just multiply that with T.
Yes, you got it.
So you will get the energy. Okay. So I think this chapter is also completed. You go through all the questions and examples. Okay.
Yes.
So that your static electricity and electrical quantities and electric circuits, all the 3 chapters are completed.
Okay, sir.
And what about magnetism?
We don't have that, sir.